Hey everybody, it's Mr. Lambert with your bell ringer for Friday, October 30th, 2020, the day before Halloween. I promise these won't be too spooky. So these shouldn't be too scary. These should all be things that you have done already so far this year or last year. So again, while you're watching through today, try these out when I ask you to. Write your answer in on the side or choose it from the choices that are there, and then move on to the next. All right, here we go. So for our first question, we have, it says find the quotient. That means we're going to be dividing. We have 6 24ths divided by 2/8. Again, 6 24ths divided by 2/8. Go ahead and type your answer in on the side, and we'll check it here in just a second. All right, so I got 6 24ths times 2/8. Again, this is division of fractions, so we're going to keep, change, and flip with our fractions. So we're going to keep our first fraction the same, be 6 24ths. The change is change from division to multiplication. And then we're going to rewrite our second fraction upside down, 8/2 instead of 2/8. All right, and now that we have done this, ladies and gents, this is now a multiplication of fractions problem, and we can multiply straight across. So 6 times 8 is, of course, 48. And 24 times 2 is actually also 48. Crazy. So our answer here is actually 1. 48/48 or 1. Because if you have all the parts of the whole, you've got the whole thing. So 1 should be our answer there for this one. Good job if you figured that out. If you got to 48/48, that's pretty good too. Just remember, you see that division sign, you have to make sure you change it to multiplication and flip it before you work with anything. All right, let's move on to the next problem. Here we go. All right, question number 2, find the quotient again. Again, this is going to be long division, so you're just going to work this out like regular long division. Go ahead and give that a try, and we'll check it out here in just a moment. All right, guys and gals, let's do it. So again, I don't know my facts for 13, but I do know my facts for 10, which is pretty close. So I'm going to start with chunks of 2 and see how many times I think it can go in. I'll talk through how I'm thinking about this. So I know that 10 can go into 30. This is 34 here. 10 can go into 33 times, but I have this 3, and 3 times 3 is 9, so this would actually be 39, which is going to be a little too big, so I can only go 2 times. So 2 times 3 is 6. 2 times 1 is 2. So we've got 26. We're going to subtract that out. 4 minus 6 we can't do, so we'll borrow from here. We'll make that a 14. 14 minus 6 is 8. And now 2 minus 2 is nothing. So we're going to bring our next digit down, which will be our 5. And I'm running a little bit to the side here. My little writing tool is too big. All right, so 10 again could go into 80 8 times, but because of that 3, I think it's only going to allow us to do 7 times here. So we're going to try 7. 7 times 3 would be 21. Carry our 2 up. Ooh, that's going to be 9. That's going to be too big. So we need to try 1 digit less. So let's try 6. Uh-oh, kind of messed up our 2 there, didn't I? So let's try 2 and 6. 6 times 3 is 18. Here our 1 up. And then 6 times 1 is 6 plus 1 is 7. That looks a little better. We'll have to borrow here again. But 15 minus 8 is 7. Now 7 minus 7 is nothing. We're okay. Let's drop our 8 down. I have 78. Now 13 again. 7 is going to be too much. We can try 6 and see how that does again. Actually, we already know 6, right? Because we just did it for our last one. And it was indeed 78. So I have 78 there. I'll subtract 78 from it. And hey, guess what, guys? We got a remainder of 0. So our quotient was 266. Again, you're just going to go piece by piece as you go, guessing and checking as you go. You saw there that I had to guess. One of my guesses wasn't right. So that happens from time to time. You just try the next digit that you can and move forward. All right, let's move on to the next. Question number 3 today. All right. We've got 4 and 99 hundredths, or sorry, 40 and 99 hundredths times 2 and 1/10. Go ahead and multiply that out. Remember what our tricks for multiplication that we've talked about this week? Forget it while you're multiplying and then add the decimals to your answer. We'll check that out here in just a second. All right. So I have 40 and 99 hundredths, and I'm going to multiply that by 2 and 1/10. Again, I'm going to line these up like those decimal points aren't even there. I'm going to pretend like they're not there while I'm working. So 1 times 9 would give us 10, or 9, sorry. 1 times 9 again, 9. 1 times 0, 0. 1 times 4 is 4. Easy breezy. Now we're going to pretend like that's not there, so that we're going to treat this like it is a 20. That means I need to add a 0 since I'm dealing with a power of 10, and now I can treat it like a 1 when I multiply. So 2 times 9 gives us 18. Carry our 1 up top. 2 times 9 would be 18 again, plus 1 would give us 19 this time. Carry our 1 over. 2 times 0 is 0, but plus 1 would give us 1, and 2 times 4 is 8. And now we're just going to add these like normal. So 9 plus nothing is 9. 9 plus 8 is 17. 7 will carry our 1 over here. 1 and 9 is 10, so I'll drop the 0 and carry my 1 to the next column. 1 plus 1 is 2, plus our 4 gives us 6, and 8 by itself would, of course, be 8. Now I've got 86,079, but of course I need to deal with my decimals because that's way too big for basically 40 times 2. It should be something close to 80. So I know my decimal point should go right here. But does that work? Well, we've got 1, 2, 3 digits to the right of our decimal point in our question, and now we have 3 to the right in our answer. That would be correct. All right, guys and gals, you are rocking along. Hope you did well with that one. If you're still having trouble with those, make sure you check me out during office hour. We can do a couple of those together. It's basically regular multiplication. You just got to figure out where those decimals go at the end. Almost done here. All right, greatest common factor, and we need to rainbow method these guys. So remember that a factor is an integer that is multiplied by another integer to get a product. We're going to use the rainbow method to find the greatest common factor of 28 and 42. So let's see. Let's do 28 over here. We'll do 42 in a different color. I'm going to let you guys try this out, and then I'll check and see what you got here in just a moment. Okay, so I've got 28 and 42. I'm going to start with 28. I know that 1 and 28 are factors. And there's my first rainbow. I know because 28 is an even number, I can do 2. So 2 and that would be 2 times 14. But 7 is going to work then. Let's see. I can also do, can I do 3? 3 does not work out. 3 times 9 is 27, so it's awfully close. Although 4, I believe, will work out because 4 times 7 will give me 28. And I'm getting close to the end of my factors because 4 and 7 aren't that far from each other. Just need to try our last numbers in between. 5 is not a factor of 28 because all multiples of 5 deal in 0, end in 0 or 5. And 6 is not a factor of 28. And the closest that we get is 24, which is 6 times 4. So actually, these are our factors. We have whoop and whoop. I have 1 and 28, 2 and 14, and 4 and 7. Now let's look at our factors of 42 so that we can compare here at the end. So we have 1 and 42, of course. I'm guessing there's going to be a couple more factors here, so we'll give a little more space. We'll do a downwards rainbow this time. 2, of course, will work because that is an even number, and that's 2 times 21. Will 3 work this time? Actually, 3 does work. Have to know because, well, this 2 could be part of a 12. That would be 3 times 4. And then another 3 times 10 would be 30. that would give us 14. So 3 times 14 also gives us 42. Can 4 work? Well, I don't think 4 does because the 2 multiple was 21. That means 4 probably does not work as a multiple of 42. So we'll have to move on to the next. 5, of course, will not work. And 6 does actually work because 6 times 7, I know that one from my elementary MACFAC stuff. That is indeed 32. So our factors of 42 are 1, 2, 3, 6, 7, 14, 21, and 42. Now we need to find the biggest one we have in common. So let's switch to a new color. We'll switch to purple and see what we can find. Now it's 42 we do not have in common. The biggest one here is 28, and we also do not have 28 in common. Check out our next number on both of these. Is 14. We do have 14 in common. That means our greatest common factor between these two numbers, the one that they have in common that is the biggest, is 14. There you go. Again, you'll need to know this because it will make multiplication and division, and especially when you're dealing with simplifying fractions, it will make it way easier for you. Last but not least, our last question for today. Question number 5. Finding the difference. And ladies and gentlemen, we're just going to be subtracting here. So you've got 14 and 365 thousandths minus 25 and 83 100ths. Remember what you need to do when you are subtracting with decimals. There's a trick here. See if you can figure that out, and we will check it here in just a second. All right, guys and gals. So hopefully you figured out that what you needed to do. I'm just going to erase this guy, and I'm going to put it over here. So I have 14 and 365 thousandths. But if I'm going to subtract this out, I need thousandths up here. So I'm going to have to add a 0. And now I can do the work just like normal. So we're just going to subtract straight down like a normal subtraction problem. Our answer, our decimal will go straight down. So 0 minus 5 can't do, so I'll have to borrow from this 3 and make that a 2. So now I've got 10 minus 5, which is 5. Got 2 minus 6, which I can't do either, so I have to steal from this 8 and make that a 7. All right, now I've got 12 minus 6, which is indeed 6. 7 minus 3, which is 4. 5 minus 4, which is 1. And 2 minus 1, which is 1. That would give us an answer of 11 and 465 thousandths. So if we look at this, 11 plus 14 would give us 25. So the decimal seems like it is probably in the right place. We know this would be in a reasonable answer that is accurate for us today. All right, ladies and gents, I hope you did well on these today. Next, you are going to be hopping on in and doing another lesson where you're going to be watching a video and taking some notes. And then you'll be moving on. Actually, no, today's Friday. What am I thinking? Today you'll be hopping on and finishing up an assessment dealing with addition and subtraction we'll be dealing with addition and subtraction of equations using absolute value. We'll be doing graphing. We'll be comparing integers, positive and negative, a lot of different stuff today. You will see a little review video with some questions here right below. So check those out and then try your assessment for today. Good luck on those. If you have any questions, make sure you give me a call or shoot me an email or hit me up during office hours so I can help you out. Hope you guys have a great day. Good luck on your assessment today. Do your best. Don't sweat the rest. All right, guys. Have a great day.